I think I've learnt a lot from Ronan, but I think I've also heard from Ronan some of the stuff that I'm going to repeat to you from an Irish context of what we've learned through our BIM journey and BIM lessons and the projects we've worked on. So I think the problems are the same and they repeat regardless of where you are and who you are, so hopefully that will come across. I'll just give you a brief introduction to ourselves. I'll just talk about maybe about some of our BIM projects, some of the things we've been working on. And then I'll just talk through a structural case study. It's the Mercer Institute for Successful Ageing in St James's Hospital. It's a project we've worked on for a couple of years, which is more or less finished on site now. And I'll just talk to you about what worked, what we thought worked really well, what we used it for really well, what didn't work so well, and what we've been working on since, and some of the stuff we've taken through into future projects as a result. Sorry, I'm just going to try and change this because I'm not seeing the screen. And we'll take some questions at the end, as Richard just said. So just a brief introduction for those who don't know us. We're a consulting civil and structural engineering firm. We've been around for 78 years, so we've seen a lot of technology come and go. Our main services are civil and structural engineering, safety management, including PSTP, project management, economic development, and a science certifier role. We have a number of offices throughout Ireland, London, Saudi Arabia, and also in Africa. As I mentioned, we've been around for 78 years. We've seen a lot of sectors and worked in a lot of sectors, and a number of which have been award-winning. We've worked in over 38 countries internationally. And these are just a quick snapshot of the most photogenic projects I could find to fit on one slide. And some of the projects that we've been working on in BIM, the first real one we did with the full design team and full coordinated effort with the design team was a data centre in North Dublin a number of years ago. We were technical advisors on that role and produced a BIM model to LOD 200, which was then given out to contractors to further develop during their detailed design process. We've worked in a number of projects in Saudi Arabia and have used BIM processes to different levels and effects. This was a residential development in Jeddah, a 14-block building, and there was as much going on underneath the podium slab as there was above it. And I think our technician had some sleepless weeks and nights making sure that he could make both the curve and a ramp work at the same time. You'll see there in the very front. So YouTube was his saviour in that effect on that occasion. Again, this is another building in Saudi Arabia, a biomedical building. We just did the scheme design on this, so a low level of detail, but used the model just to figure out where the structure was going to be so the architect could produce their plan and sell that to the client. We've used BIM processes and modelling through a number of PPP bids in Ireland, and have been working at the moment, going to tender with the Department of Education on a school in Enniscorthy. The department decided to challenge us in every way on this one. I think there isn't a straight line in the building, and I think every roof has a different angle and curve. So again, it's one that we had a steep learning curve on to figure out our reference planes, our curves, and making sure that both us and the architect had the same thing on our models. We've also been working with the QS a good bit on this one. We've been getting down to the level of trying to pull out steel quantities, lengths, member sizes, so that he may be able to use that on his bill of quantities. We've always disclaimed them when we've issued them on the model. We're not 100% sure that everything's going to be right, but that's why we have him. He'll do a cross-check on the 2D drawings to make sure that the stuff that's coming out, that we're spitting out of the model, is what he's seeing as well when he's doing a quick check with it. We're working on a pharmaceutical extension at the moment in Waterford to a warehouse. Again, this one we're just doing a bit of lonely BIM on. We're doing it for ourselves, and we've done that in quite a number of our projects where we've just taken the decision to model stuff and do stuff in BIM in-house, even if no one else in the project is using it. We do that for a number of reasons, some of which I'll go into in a while. Again, another lonely BIM project is our new medical block in Naas Hospital. It's out to tender at the moment, should be due back. Again, there was an awful lot going on underneath the ground in this one. We had a basement and differing ground conditions across the site, and we primarily used BIM on this project to figure out where we want to put the levels, where we're going to put our pad foundations, where the basement was, to make sure that we had stuff in the right place, that we weren't transferring loads from a pad onto our basement walls. So we're using BIM to figure out what was going on the ground more than anything else on this project. And it's very easy for us and me to talk about BIM and just think about the buildings, but we've used BIM and quite successfully on this project in Saudi Arabia. Again, it's the Bonded and Re-Expert Zone in the King Abdullah Economic City. It's a site of over 3.6 million square metres, and we were involved with the project from the start with our economic development consultancy service. We've modelled all the infrastructure and roads in 3Ds and all the surfaces in 3D on this one. We thought we were doing lonely BIM on this one in Franklin House in Dublin. Again, it's something that's on site, currently being built. But between ourselves and the steel fabricator, we're exchanging IFC models to see what we can learn from each other and see what we can benefit from having IFC models of more or less the same thing. But again, it's something we use. There's a lot going on, the elevations and levels on this building. Again, a lot going on at the couple of lower ground levels at varying levels. It's something that we found very useful having a BIM model for. And again, another one that's on site, another case of lonely BIM, where it's a primary care centre in Dublin. And again, we just took the decision to do this in BIM for a number of reasons. We're only detailing this in 2D CAD, but we're using all the elevations from the model that we just detailed in CAD. We're working on a number of waste to energy facilities in the UK, and again with an M&E consultancy, we're doing coordination of clash detection to see how tightly we can make these buildings. No one wants to see a big waste to energy building. We're trying to see if we can space manage this to the best effect. So what I'm really here to tell you about is what we've learned during our time on the Mercer Institute for Successful Ageing in St James's Hospital. So that's what it looks like, the structural model. I'm going to apologise to all the architects for our rendering skills. It's located in St James's Hospital campus in Dublin. It's over 40 million design build project, and we're working on the project with BAM, who were the main drivers of BIM on this project as far as we could see, and were the main reason we did it and have done it in BIM. There's two main sections of the building. There's a 7-storey section and a 4-storey section, and there's also a small 2-storey section. And delighted to report the project is actually finished on site last week. The structure is primarily in situ reinforced concrete below ground, and all the vertical structure is in situ as well. There are post-tension concrete horizontal superstructure, so the floors are all post-tension concrete, and we've, as you can see from some of the renders later on, we have a structural steel frame on the roof for the plant. The facility is over 15,000 square metres and has 100 beds in it. So again, another couple of renders, and just that's it being built at one stage during construction. So you can see very quickly that what we're looking at, what we were looking at when we were designing it, is more or less what you see when you get there, and thankfully what you see when it's built. So what worked well for us on the project, I think Ronan mentioned it a couple of times, it's visualization. It's just seeing see in 3D what you're doing. I think as an engineer, we all think in 3D anyway, and we all work in 3D. We've been analysing and using analysis packages in 3D for a number of years. It's our natural instinct to think in 3D. And why would we, or why should we, convert that to 2D information so that someone else starts picking it up in 3D is beyond me, or how we've ever got to that. We now have the technology and the ability to think in 3D, detail in 3D, and send that information out in 3D to stop the transferring issues and the errors and miscommunications that can happen between the 3D and the 2D process. I think Ronan mentioned it as well, and it's given really good examples on it. Clash detection, I know Anthony from Ethos is going to speak to you a lot on this one as well. But the stuff we found on this by doing a clash detection process during the design phase that we would not have found until the thing got on site in this job. Definitely, we can say that hand on heart. And to be able to get rid of that and not have those calls coming from site saying, oh, there's a pipe, or there's a beam, or there's a beam, or there's a pipe. Yes, we still got some of those calls, but they were definitely decreased as a result of what we did on the project at the start. I think we gave out about it at the start of the project. The collaboration system, the common data environment, the file naming system to PAS 1192, and having to comply with a standard. It's not something that we all do. As engineers, we all do it every day in what we design. But I think very often we've all forgotten about how to apply it for the way we collaborate with each other and the way we file name stuff and the way we send stuff to each other. That we send stuff and receive stuff in the way that everyone expects. I think we kind of lost that a little bit, and I think we really got back into it on this project where we were having to comply with the PAS 1192 standard. The project was achieving or aimed to achieve what we thought in 2013 was level 2, PAS 1192. Looking back 2-3 years now, is it different than what we thought? Yes, but we definitely gave it a good stab. But I think having the common data environment and having everything called the way it should be it can be a godsend at times, that you can just go to somewhere, a space, and know that something's going to be there and you can get it. Instead of having to make a phone call to say, I think you sent me that email, I lost that email, or I saved it somewhere, or I saved it into the wrong job. Just going to the common data environment and finding what you want when you need it. It's really useful and helpful. Changes and revisions. So we put a lot of time and effort into getting the model built at the start. And we had to do a lot more work up front than we maybe normally would in the process. So we spent a lot of time getting the model up and right. Once that work was done earlier on in the project, we were able to use that model to much greater effect to capture changes and revisions. And we were able to really deliver for the contractor when required. So when they needed a change done, we were able to react to that and have something issued very quickly, quicker than we would do if it was just a plain 2D process. But it did take that effort at the start of the project to be able to do that. So what worked well for us are visualization, the CDE, the file naming, changes and revisions, and the clash detection. What didn't work so well? We really struggled with our drawing quality at the start. And the stuff we were producing didn't look right, wasn't what we wanted to be in 2D. And I know a lot of people struggle with that when they start the BIM process and using an authoring tool, that they just can't seem to get what was out, what they wanted out of it. You got to stick with it. We stuck with it, and we improved it, and we'll show you that later on. But we had to learn, and it took a bit of time, and it took a learning curve. I think Ronan touched on it earlier on as well. We probably did too much too early on this project. Some of that was driven by the need of it being a design and build project. Stuff was required really fast on site for someone to get started and get building. We probably did too much. A good example is we probably put way too many of the smaller cores into our model too early. And we did it when the specialist contractor wasn't on board. When the specialist contractor got on board and started feeding some more information to us, the stuff we had done had to change. It wasn't the end of the world, but what we really think about now is at what stage do we put stuff into our models? Should we wait and put that in slightly later on in our process, or should we do it now? And it's a question that we ask ourselves within the office quite a lot, is when should we put that into the model? Should we wait, or should we do it now? But the other thing that Ronan has mentioned, and I'll echo, is it's really important that the people who are providing specialist advice into the building are available or there at the right time. I think if we had maybe had the mechanical subcontractor procured at an earlier point, we might have been able to avoid some of the stuff, some of the reworking we had to do. But it's a chicken egg. How do you get it procured if you haven't got the model or the job up to a sufficient level of detail to get some pricing and costing? So again, that's a project issue that we do discuss. What else didn't work so well? Information overload. I think we started the job and there was just so much information everywhere available to us that we just didn't know what to do with it and how to process it and where to start. But that's not necessarily a bad thing, because we had it all and we were able to use it all. The speed of initial delivery for design and build contract I think we found difficult. With the BIM process, we're finding we have to put more time in before we can actually issue anything. So we can't just issue a drawing out a week or 2 weeks after we start the project. It's going to take 4, 5, 6 weeks, depending on the project, to get us to be able to do something or issue something of value. And I think we were getting under pressure to issue stuff while trying to do a couple of things within the office, both design and detail. And I think that whole design and build, I want to get out of the ground straight away, really kind of, with the BIM modelling, it took a bit of work to get us to where we needed to be to get the contractor happy on site. Ronan mentioned the point cloud surveying. There was one done for this of the neighbouring buildings. We could never get it to work in Revit. I think we've all tried in the project, across the project team to get it work, so it's still one on our list to sort out and go back for. And we struggle with tracking the changes on the BIM model. We were asking questions about when did that column move, who moved that column, where did the beam, where is that beam, where did that move? You know, we were having trouble tracking that, and we come up with a solution for that. We tried to use in every structural model, there's an analytical model behind the physical model, and we tried to use the analytical model to affect in other packages, and we just couldn't use it. And what we've learned is that we were drawing the building too fast. We were drawing the building in the effort of getting 2D modeling. We weren't drawing the building to both do 2D drawing and also use the analytical model. And that's something we've learned a lot, and I can talk about it later on. I think it catches a point that Ronan mentioned earlier on, that we were doing a lot of this for ourselves. We weren't doing it for others. And if maybe the technicians, knowing what they know now, had drawn the building or modeled the building a different way, that model may have been able to be used to greater effect, and I'll touch on that later on. So what we definitely learned how to improve our drawings, and I'd argue that I think the stuff coming out of what we use, Revit, is better now than what we would have produced in AutoCAD. It's more consistent, and it's definitely something that we have learnt on. Compliance with PAS 1192. It's great to read a standard, and I know we've all read the standard, and you go, what does that line mean? What does that line mean? What does that paragraph mean? There's nothing like just diving in, learning from something you've done wrong and said, what does the standard say about that, and trying to go backwards. We started putting in splash screens now with all the information that PAS 1192 needs, so that we can keep track. We're using these splash screens, just a plain text sheet on all our models, that we're putting in all the information that's required for compliance with PAS 1192. Yes, it's another admin task, but once you have it, and it's essential and it's brilliant. Similarly, with all the data that was out there, our lead technician went on holidays for two weeks of this process towards the start of the project, and he had stuff linked to the model all over the place. And we spent a lot of time figuring out where that model was linked, how to change the model, where that model was, where everything was saved on our server, not to mind anyone else's server or common data environments. And again, we've just started splash screens of information of where the architectural model is that's linked, and where it is you go and change that. Just pointing other people on the project in the right direction to what they might want to do if someone's missing. So what we've been working on since, I mentioned it a couple of times, the model on the left is our physical 3D model from Revit, and the model on the right is our analytical model in our analytical software, the one we use as ETABS. So we've put a lot of work and effort into making sure that we're benefiting from having a 3D model, not only for what we do in Revit and 2D drawings, but also using that in our analysis package. So I really don't want, and I hate us having to redraw and redo anything. The model's already there, and I just want to transfer it. I don't want to have to redo something in another package. There's a lot of learning in it. There's a lot of issues that arise by having an incorrect or improperly built 3D model that will look fine in Revit and on 2D drawings, but won't work when you bring it into the model. And we've learned a lot on the way we have to model to use best effect for the analytical model. And a rule that we now have in the office, kind of built into everyone now, is respecting the node. So a key part of any structural analytical model is a node. And what you can do if you draw or model your building wrong in an authoring tool, the node will start moving around and get lost. And if that node gets lost when it gets moved to the analytical model just falls down. So we figured out there are steps of ways we have to draw to make sure that the node remains where it needs to be and is intact. A simple example that we had recently was we have a number of roof beams which are inclined and at an angle. So what the technician was doing was he had his two columns, he was putting in a beam at any level, he was trimming the beam when it was at 90 degrees to the column, he was moving the beam up and then inclining it to the angle of the roof. And what was happening was the node was also getting inclined. So what we've now made him do is put in the beam, align it, put it in the right direction, and then trim it, and then the nodes will be at the right place. So it's a simple thing that we can do, that the technician is now aware of the analytical model. Small steps to make sure that the model is not only serving the technician, but also serving another user within our office, not to mind somewhere else. So it's the small things that we have to do to make sure the model will be usable for both ourselves within our internal processes and also for those externally who need to use it. We've been looking at all our internal procedures with regards to complying with BS 1192 and PAS 1192, and working through them to make sure that we are and doing things right in accordance with standards. Something I think which I mentioned has been forgotten. And we've also been busy working on constructing and getting something else and getting something built. So hopefully that was some use, and I know the lads will have some further case studies and some examples. So thank you.